Hello guys, this is Pranav and I am going to discuss on the topic of big Mart sales prediction. So this project is about predicting sales from particular outlet. So first of all, to perform this project we need some libraries that are pandas, numpy, seaborn, matplotlib. And after importing these libraries, I have imported this data set which is available on Kaggle, and this data set has about 12 attributes and some thousands of entries. And then here I have done some statistical info which tells us the mean, standard deviation, minimum value and maximum value. And then I have checked the several data types in each attribute. And after performing that, here I am checking the unique values in each dataset, that how many values are there in each attribute. And here after that I am doing the null values check, how many null values are there in each attribute. So here you can see that item weight and outlet size contains thousands of null values. And after that, here we have to check the how many categorical attributes are there in our data set, and then which categories are not required, we can remove them. So here item identifier and outlet identifier are not required, so I have removed that two attributes. And then here I have print out the categorical columns. So here you can see that item fat contains four attributes, but there is some issue regarding low fat and regular, as their three attributes contains same data but with different names. So we need to address this issue. And then I have filled the missing values, that is in item mean there are several missing values. So, and here you can see that there are several null values in this item weight category. So here I have applied this function to remove the null values, and after applying this function the null values are gone and the result is 0. Same thing is done with the outlet size, and applying by the aggregate function I have removed all the null values and the null values count is 0. And here you can see that item visibility has about 526 null values. And to address this, I have replaced the zeros with the average of item visibility, and all the null values are gone. And in item fat content there were low fat, regular and several attributes, but containing same data. So here I have combined that three attributes in two categories. And after removing all these missing values, here we move towards the creating new attributes which will help our data set to run smoothly. So here I have created a new item type. So there were this FD, DR and NC, which is basically food, non-consumable and drinks, which is short form. And here I have specified them in a proper manner which will be easy for the data set to process and for the user to understand. And after that, here I have created new outlet here for which will remove the small value, which will create a small values. So establishment here, so in the outlet establishment here there were huge amount of values such as 2013, 2014, so which is not easy for the data set to process. So I have minus the 2013 from all the outlet establishment here, which will be easy for our data set to process. And after doing that operation, Here I have performed some exploratory data analysis on various attributes of our data set. So here you can see we have performed a bar plot on the item weight, and same goes with item visibility, and same with item MRP and the outlet sales. This graph tells us about how the each attribute is performing. And here you can see the item fat content, which tells us about about the various item, how much amount of fat is how much amount of fat is there in each item. So there are most amount of food containing low fat, and then there are these several item types with their various with the counts. So here you can see that snacks are popular, and fruits and vegetables are the most preferred items in the Big Mart sales. And here are the establishment year. So in 1985 it was the most amount of outlets were established, and in 1998 the least amount of outlets were established, and every other year is stable. And then comes the size of the outlet. So most amount of outlets are small, and then there are some outlets which are the size of medium, and the outlet size which is high are the list. And then are the location type. So there are three types of location, that is tier 1, tier 2 and tier 3. So here you can see that tier 3 are the most preferred location. And there are several outlet types. So there is a supermarket, which is the most preferred outlet type, and all other outlet types are less than 1000. And here I have performed a correlation matrix on different attributes, which are item weight, item visibility, item MRP, outlet establishment year, item outlet sales, and outlet years. And after they performing this, there is label encoding. So label encoding converts the categorical attributes into numerical values, which helps our dataset in the model building. And there I have performed one hot coding. That is, this operation creates one column for each category. So here you can see that this one hot coding has created each each column for each category. And then after doing one hot coding, I have done this split the data set into train and test. So in the X column, in the input column, there are some attributes which are not necessary, and we need to drop that. And after doing the train test split, there is some libraries which are necessary for our model for training and testing. Cross validation, which is required for us code, and mean square error is also required to check this code. And then training of the model is done. Then predict the training data set, and then we need to perform cross validation. And building our model, we need to perform a linear regression algorithm to predict the sales of each particular outlet in various locations. So here I have imported a linear regression from sklearn linear model, and then performed the operation. And here the graph tells us about the positive. So the graphs which are about tells us about the positive coefficients about the item fat content, item fat content 1, and the bars which are below is the negative coefficients such as outlet size 1, outlet size 2, outlet size 0, and in the between which there is no space. There it is because that there is no uh, amount, there is no particular data which is suitable for that model coefficient. And that's all from my side. Thank you.